Welcome to Properties and Attributes of Polygons. Today's objectives are to classify polygons based on their sides and angles, and to find and use the measure of interior and exterior angles of polygons. So here we have an example of a polygon. So what can we notice about this polygon? What falls under the description of a polygon? Well, a polygon is a closed plane figure formed by three or more line segments. So a polygon, first off, has three or more line segments. Polygons are flat, they're two-dimensional, so they're plane figures. And each segment intersects exactly two other segments only at their endpoints. And no two segments with a common endpoint are collinear. So each segment, for example, if you look at segment AE, it only intersects with AB right here and with ED right here. So each segment intersects exactly two other segments only at their endpoints. So let's look at two figures now and tell whether each figure is a polygon. If it is, we're going to name that polygon by the number of its sides. So if we look at figure A. Now, figure A is a closed plane figure. It has more than three sides, and each segment intersects exactly two other segments only at their endpoints. So this figure intersects here and here. This segment intersects here and here. This segment intersects at these two endpoints, here and here, and here. So figure A is a polygon. Now to tell what type of polygon it is, we name it by the number of sides. So we look at our graph here, we count the sides, 1, 2, 3, 4, 5. It's 5 sides. So we call this polygon a pentagon. Now, figure B is not a polygon, and this is the reason why. If we're going to name the segment AB, AB intersects, let's call this segment CD, right here. The segments can only intersect at the endpoints. So let's write that. Segments can only intersect at the endpoints. So figure B is not a polygon. Now, depending on the different sides and angles of polygons, there's a different way to classify them. So these two figures here are both polygons. This first one here has 1, 2, 3, 4, 5, 6 sides. So this is a hexagon. But we can say more about this hexagon. Now, if all the sides and all of the angles are congruent, we call it a regular polygon. So regular polygons are equilateral, meaning all the sides are the same, and equiangular, meaning all the angles are congruent as well. So our figure on the right here is a pentagon, and we would say it's a regular pentagon, because all of the sides are congruent and all the angles are congruent. Another way to classify polygons is by determining whether the polygon is concave or convex. Now, to determine whether it's concave or convex, you want to look at the diagonals. Now a diagonal is a segment that goes from one endpoint to another endpoint. So a diagonal is a segment that goes from one endpoint to another. So, if that diagonal can go outside of the polygon, we say it's concave. So if it goes outside the polygon, we say it's concave. Now, if all of them are inside the polygon, we say it's convex. So to determine whether a polygon is concave or convex, first look at the diagonals and then analyze if any of the diagonals go outside, it's concave, and if any of the diagonals stay inside, they are convex. Now to find the sum of the interior angle measures in any polygon, you want to be able to break down the polygon by drawing diagonals. Every time you draw diagonals, you will get different amounts of triangles. And since you already know the sum of the interior angles of a triangle, you can figure out the sum of the interior angles of an entire polygon. So let's examine this. So for the first polygon, let's look at a triangle. We know triangles have 3 sides, and within a triangle there's only one triangle. So the sum of the interior angle measures of a triangle is just 1 times 180, which equals 180 degrees. That makes sense. Now if we have a quadrilateral, now quadrilaterals have 4 sides. If you draw a diagonal through a quadrilateral, we have one triangle here and another triangle here. So in a quadrilateral, we have 2 triangles. So to find the sum of the interior angle measures of a quadrilateral, we just multiply the number of triangles times 180. And we get 360. So the sum of the interior angle measures of a quadrilateral is 360 degrees. Let's move on to the pentagon. Pentagon has 5 sides, and if you draw diagonals through that, you see we have 1, 2, 3 triangles. So there are 3 triangles in a pentagon, so you just multiply 3 times 180, and that gives you 540. Let's look at the hexagon. Hexagon has 6 sides, and within the hexagon we have 1, 2, 3, 4 triangles. So there are 4 triangles, so we just multiply 4 times 180, and that equals 720. So here's the pattern. If you just take the number of sides, subtract 2 from it, and multiply that by 180, you can know the sum of the interior angle measures of any polygon. So for a polygon with n amounts of sides, if we just subtract 2 from that any number and then take that and multiply it by 180, we can find the sum of interior angle measures for any polygon. And this is called the polygon angle sum theorem. And this helps us find the sum of the interior angles of any polygon. Okay, let's use the polygon sum angle theorem to help us find some interior angles and individual interior angles. So I want to find the sum of the interior angle measures of a convex 15-gon. So if it's a 15-gon, that means that the number of sides equals 15. So I know that the polygon angle sum theorem says that n minus 2 times 180, that equals the sum of the interior angle measures. So I just do 15 minus 2 times 180, so 13 times 180, and that equals 2,340 degrees. This is the sum of the interior angle measures of a convex 15-gon. For part B, I want to find the measure of each interior angle of a regular decagon. So first, let's find all of the interior angles. So a decagon means 10 sides. We want to subtract 2 from that and multiply it by 180. So if we multiply 8 times 180, we get 1,440 degrees. But what this question is asking us for is to find each interior angle of a regular decagon. Now we know regular means all the sides are congruent and all the angles are congruent. So if all the angles are congruent, I can just divide this by the amount of angles or sides, which here is 10. So I divide total by the number of sides. The reason I do that is because all angles are congruent. So I do 1,440 divided by 10, and each angle is going to be 144 degrees. Now, to discover what the property is of the exterior angles of a polygon, first thing I want to do, let's just add them and see what happens. So if I added 147 to 132 to 81, my answer is 360. Now if I added the exterior angles of this figure, 43 plus 111 plus 41 plus 55 plus 110, guess what? 360 degrees. So we can conclude that the exterior angles of a convex polygon equal 360 degrees. This is called the polygon exterior angle sum theorem. If I want to find the measure of each exterior angle of a regular hexagon, first thing I have to do is know that a hexagon has 6 sides. Now I know that the sum of the exterior angles of a regular polygon has to equal 360 degrees. Now if it's regular, that means all the sides and angles are congruent, so I can just divide 360 by 6, since all the angles are equal. So each exterior angle of a regular hexagon will be 60 degrees. For the second problem, I want to find the value of A in the polygon RSTUV. So all of these angles here are exterior angles. Now I know that if I add them all up, they have to equal 360. So that's what I'll do. I'll do 7a plus 2a plus 3a plus 6a plus 2a, and then I'll just do algebra to solve for a. So I have 360 equals 20a. So a equals 18. The reason we could solve both of these problems is because we know that the sum of the exterior angles of a polygon has to equal 360 degrees. And that is the end of our video for today. Thank you and take care.